Hello and welcome back to our episode where we react on the comments of you. We are back to eballonews, who had another interesting comment where he refers to a video about integration tests as a scam or integrated tests as a scam and ask us how would we react on that and how to balance the integration and unit tests.
Yeah. So as I also replied to the comment, I do think that the combinatorics issue of unit test versus integration test can be an issue, but assuming that combinatorics are a problem for integration tests, suggests that you would do all your testing in integration tests, and I think that is just something that no one would suggest you would do. I think the right approach is to have a well judged amount of integration tests versus unit tests, depending on how much combinatorics issues you have.
I would say that here it's very important also to make distinction between what we call integrated integration and unit tests. Because sometimes the line between unit and integrated test, for example, could be whether we're using database or not. And I think honestly, in these discussions, even not that important as long as database is easy to set up. It doesn't add too much problem to running your tests.
No, exactly.
So if we take these distinctions away, then I can easily write most of my, if not all my tests in the integration level, not necessarily integrated. So that's one way to look on that, especially with modern tools like Docker. Another thing is that, yes, there is a combinatorial potential explosion, but it's the same whether you test with the integrated or not, there is still potential explosion like this of all your features and potential combinations of your applications. And how we deal with it, we build these lines which are important. So you don't necessarily have to do all the combinations for ponds in this example that video, fish,
exactly.
hungry or not hungry, because you can make judgments what will affect on what not, and you will take a simplest case and just say, okay, given in the simplest case of everything, I just have fish hungry, and given not hungry, so you will avoid this explosion.
And also a very important factor, I think, is that in a coherent system, the different states of the different units are not actually independent. So that means that there's a lot of combinatorics that you don't get because some of the different substates of a single unit follow from only a subset of the states of the previous unit.
Yeah, so not every test should depend on every other, otherwise you have coupling of everything with everything. And basically you should be able to see the differences between those things and make a judgment which parts of the combinatorial matrix are you covering, which are not. And that's actually, and you will do that either implicitly or explicitly.
Exactly. And probably if this is a problem, then you might have a too complex system.
Too complex or not well, or you need to redesign it. Yeah, well, at the end, yes, it's too complex, but maybe too complicated. Not necessarily too complex. Well, there is a subtle difference between...
Yeah. Okay, so you mean one is a necessary complexity and the other is...
something like that. But yes, you have...
that's added on through bad design, essentially.
Yes. But I would still, coming back to what eballonews says, I also agree with that, even though I am really on the integration, not integrated on the integrated environment, integration test first person. And I'm fine even to have no unit tests. Usually when I see that some area is tricky and has enough complexity on its own, I have no problem to isolate it, even to do as you would normally do, Bart, to do refactoring for testability, because in that particular case, yes, there is a value, and I will be just in very pure isolation testing on, well, unit-to-unit testing this particular piece of the functionality without putting effort into isolation. Even though by default, I would not have a problem running those things together. taking care that it's not overly expensive and not overly fragile.
I think the problem with the video that he linked, at least, it's just that it lacks nuance.
No, well, I mean, it definitely gives a good point on what to be aware of. Well, it doesn't talk about the solutions, because the solution is not necessarily to go only to the unit test. You can still
exactly.
do it with the unit. Okay, I think we can move on to the next comment. This is from Emanuele Ianni, where he says that he practices TDD when writing new features and that he doesn't use mocks. If not changing legacy code, he uses mostly fakes and the integration test to test the edges of hexagon. Inside the hexagon, everything is unit test and the feedback is quick. This all reads to me like a dream. And I think at the end we want to be more or less in the same in this situation. It just usually it's difficult, or at least for me, I like to jump into existing projects which are struggling and help them to get out of the struggling situation. So usually don't have this luxury of building everything from scratch in the way it would work that nicely.
Yeah, and he highlights that he uses hexagonal design to enable unit tests to run fast and without mocks and over a cohesive set of dependencies. And if you have an application that's properly structured using hexagonal design, then indeed you can test the full chain of logic really quickly with a component integration test, one that only goes to your different parts of your logic.
Yes, theoretically. Although in practice, first of all, I don't think you necessarily have to practice the hexagon. It's one of the ways to do that. You can also have good structures outside of hexagon. I need still to see a good real-life hexagon implementation, because those which I encounter when they under the hood end up sometimes even worse than if they were just layered. It's not that easy also to implement, in my opinion. But it's context dependent. So my just point is hexagon is not a silver bullet. I saw implementations that were not very nice of hexagon, but it can help if in the proper hands, as every technique properly applied, it can be very nice.
Yeah, it's the craftsman that makes the
it's all
the work, not the tools.
Yes, they say beauty in the eye of beholder, tool in the hands of the craftsman.
Right.
Yeah, I like also the point. I don't use mocks. If not changing legacy code, I use mostly fakes. I think that's a good one. Distinction about we talked a little bit earlier in the previous episode about mocking external dependencies versus mocking internal dependencies. And here, I think this is another going into more details, that sometimes it's good to be able to mock internal dependency, especially when you're refactoring something, especially when you need to do something and it's not testable. It's not designed for testability, or not in your particular slice not usable. So you can use temporarily usually these mocking techniques. And just a reminder, these mocks, in my opinion, as far as I know, historically, they appear to be as a technique to refactor legacy code, not as a technique to build the new code initially.
What's the difference between a mock and a fake?
Oh yes, and the fake. And the other thing that I like also fake sometimes. So fake basically replaces some implementation. Let's say, okay, let's for simplicity's sake, we have a database repository, and if we cannot use the Dockerized database or some other lightweight to have a real database for our test, we can say, what, our database repository is simple enough, it just reads, writes. We will make in-memory implementations that will just have its state in a hash structure or whatever, and will emulate the real repository. And the benefit of it, in comparison with the mocks, with the vanilla mocks, you need to explicitly say, you will get this call, answer this. You will get this call, answer this. Or maybe you can have some defaults, but they are usually not very convenient to build. Whereas with the fake implementation, you don't need to do that. You just say, this is my fake implementation. Whenever whoever comes with whichever, it will just accept a request saying put this item, it will save it, and it will get it back. I don't have to manually to make micromanage its state. It will manage its state.
It's a lightweight implementation of the dependency that already has the behavior that the test requires.
And what is
or the object under test requires.
What it gives us strategically very important. It eliminates or decreases to negligible state the problem with refactorings. Because if you're changing the way how you work with that repository, for example, somewhere, you don't need to go through all the invocation and add a parameter or change the which particular method is called. As long as the data arrives to the repository, it will be the same. You maybe just implement a new method, for example, which reads with a different filter or whatever, and that's it. So on any change in your mocked application, you only do one corresponding change in the fake object, whereas with the mocks, with like verbose mocks, you need to go through every invocation and change it, unless you have some kind of utilities that aggregate this for you, which kind of builds the same fake but in a less convenient way.
So enabling this is a good reason to use with interfaces instead of...
Yes, although again, in practice, I prefer to use the real thing and not to use fakes until it's really necessary. Where I do use the fakes is actually on the boundaries, because I prefer when I have external dependencies, I prefer instead of mocks there to use the fakes.
Right.
Because then it allows me to have a very nice external context, my external context, which will be also very much easier to maintain than if I will be scripting my interactions for every test, saying, okay, I will come to you with this particular get request with these details, this stuff that I might want to have for contract test, but not for my functional test, which involve integration with external parts.
Yeah, so you're basically saying having an interface to your external dependencies is much easier than configuring wiremock, for example.
In longer, when you have lots of interactions. Because, there is a curve and there is a point when it becomes more difficult. If you just have one interaction, of course, it's much easier to do with wiremock, because in wiremock you just say, okay, you will get this get, returns this JSON. But when you have multiple calls, especially when your state depends on what you're putting there, you expect from other call to get something back. Then it becomes quite tricky to keep those things in synchronized. And that's the same problem with external dependencies as well as internal. So the fakes help you to keep the things consistent. So one thing is that you have to do less changes if you change the interaction, but they also allow you to keep your state, these assumptions more consistent with each other. But I think as we talk again, we should definitely revisit this in a dedicated talk about mocks.
yes. This is almost becoming that
mocks.
talk. All right. So shall we go to the next comment?
Yes.
Because this is a fun one. This was from Casper Witting, another one of our colleagues at Bol.com. He mentioned this problem of real world versus ideal world situations, where he always strives for the ideal world, which should be a focus on unit tests, his opinion. And then he raises that unit tests document the behavior of units clearly. And then he also says that they have an inspiring effect for keeping that standard of quality for later colleagues.
It's a good point about ideal world and the real world. And the thing with the ideal world that we will realistically never achieve it. So it's good to have it as ambition, it's good to look at that, but you don't want to sacrifice your current situation for that future.
Like it's very much like reliability, when 100% is always the wrong target.
Yes, something like that, just to have this proper balance. Well, with the documentation, on the other hand, I think it's a little bit of a dangerous concept of seeing tests as a documentation, because they do document, they do fixate, and when they're done well, especially, they can help in this way. But they're not replacement for the documentation, and they're not the documentation. Yeah, they are not a documentation, they're just another insight into how your system behaves together with the production code, which when clear can be a good self-documenting piece, and with other artifacts like implicit in the knowledge of your team and explicit some diagrams, high-level decision records, and so on. But for me, the danger is to just purely focus on the test as a documentation, that when taken too literally, you start to sacrifice the real value of the tests and maybe drive them not where they belong, because tests are not the documentation. They're helping to document, but they're not documentation, I think.
No, yeah, and like they are not indeed documentation. They're definitely not a replacement for well-written documentation that explains the context and the high-over concepts. But what I do think that tests uniquely document is the intent of the programmer for the production code under test.
Yeah, they can document once the well-written tests. Again,
of course,
ideal,
yes.
in the ideal world.
Yeah, but also badly written tests indicate expected behavior of a system under test.
Well, the problem with badly written tests is that the majority of them, it's very difficult to really get what is the expected behavior, because usually those tests, they will not be testing the behavior, they will be testing the implementation and the side effects, and you will have just a mess of everything from which you will have to derive what actually was the one who was writing trying to express with this, if he wanted.
So they are documenting that intention just really badly, because it's hidden away in all kinds of
and sometimes they don't. That might also be, they again coming back to the question about cargo call testing, they might be just writing tests to get the coverage.
Yes.
And then I threw this thing into, I got this stuff, okay, that's, I put this as an assertion, and good luck figuring out whether it was intentionally this particular behavior or it was just how it worked, and I covered it.
Okay, yes, so all right, so that was some more interesting discussion based on the feedback that we got from Casper, Emanuele, and eballonews. So once again, thanks a lot for those feedback. I think there's lots of interesting angles that we definitely haven't covered yet. So point them out to us, and I think together we can become better programmers. Yay!
Yes, and I would like to add that I really, really appreciate the comments, even though we don't always answer very quickly because other priorities, and we want to answer very well, but then we forgot recordings sometimes. Technical things happen.
Definitely.
Don't hesitate to comment.
Yes, we love it. All right, thanks, and see you next week.